Okay, so we are going to study geometry. Today we're going to focus on Pythagorean theorem. Pythagorean theorem, everybody knows that. Pythagorean theorem. And in the basic math class 1 year ago, I also talked about Pythagorean theorem. Okay, so this is a Pythagorean theorem. How do I spell? Yes, this is called the Pythagorean theorem. Now the complete statement says as follows. If we have a triangle like that, A and B and C, okay, the complete statement says that if it is a right triangle, if and only if, okay, it is a right triangle, if and only if A squared plus B squared equals C squared. This means if you see A squared plus B squared equals C squared, that means it must be a right triangle. And if it's right triangle, then A squared plus B squared equals C squared. Okay. The first, sorry, the first theorem, it was discovered by Chinese. Okay, the Chinese a couple thousand years ago. That's from literature. We see that they find out if you walk to the north 3 steps, and then another person walk to the east, okay, for 4 steps, then they find out they are about 5 steps away from each other. And it's always true. So it's amazing. So that the guy wrote down in some book. That's what we discovered that. But Chinese did not use the alphabet, letters to state the theorem. So they're never able to develop the general theorem. That's why almost no mathematics, in my opinion, it's very hard for them to derive the formulas. So the modern mathematics now was developed by Chinese, unfortunately. Now, using A, B, C, D alphabet letters, we can easily state the Pythagorean theory, right? It's just A squared plus B squared equals C squared. Okay. So 3 squared plus 4 squared equals 5 squared. That's obvious. Okay. Now, my question is, can we find other special triangles? All the length of each side or the sides are integers. Well, you can double it, right? You get another similar triangles. Just double it, and then have a 6 and 8, 10. So 6 squared plus 8 squared equals 8 squared equals 10 squared. You can double it, triple it, then you can get as a triangle. But those essentially it's the same one. It's not just because they're similar to each other. Okay. We do have some kind of formulas to generate to find out more special triangles, right triangles. Now this is is an important fact. Okay, if a triangle, this side is going to be 2n, other side is n squared minus 1, we find out this side must be, if it's a right triangle, this must be n squared plus, okay, n is the integer. Okay, so what you can verify this: 2 squared plus n squared minus 1 squared equals n squared plus 1 squared. It's not difficult to verify. Let's check that. Okay, then when you take a k, when you integer value for the k, you get lots of a special triangle with an integer length. Okay, so let's see, what is this? 4n squared, right? N squared minus 1 is n to the 4th power minus 2n squared plus 1. So right hand side is n to the 4th power, 2n squared and plus 1. Are they equal to each other? Answer is yes. Right? That's the reason this is a proof. Okay? We have to prove it. So that is the reason they're always equal. Now, then we get to get lots of triangles. Let's see. Let's say when n equals 2. N equals 2 is 2 times 2 is the 4 square. 2 squared minus 1 is 3 squared. 2 squared plus 1 is 5. So we have this one. It's not new. Okay, it was already discovered by Chinese. Okay, n equals 3. When n equals 3, I got 2 times 3, 6 squared. 3 squared minus 1 is 8 squared. 3 squared plus 1 is going to be 10 squared. It's not new. Okay, it's not new. That's what we already get. It's just double the previous one. Sounds like we don't get any new one. N equals 4. Okay, when n equals 4 is 8 squared. 4 squared minus 1. 4 squared minus 1. 15. 4 squared plus 1. 17. Oh, this is new. Okay, Grant give me another one. 5, 12, 13. Let's see if we can get that one. 5, 12, yeah. Okay, when n equals 5. And then that's going to be 2 times 5, 10 squared. 5 squared minus 1 is 24. 5 squared plus 1, 5 squared plus 1, 26. All right, so this is a 10 squared, 24 squared, 26 squared. But all the numbers are even, so I can divide by 2. So if 5 squared plus 12 squared equals 13 squared. That is the special right triangle given by Grant Moore. Great. Can you get another new right triangle? So let's just list all of them, right? N equals 6. 6, 4 times, 2 times 6 is 12 squared. 6 squared minus 1, 35. And 6 squared plus 1, 37. Okay, this is a new. Okay, just one more, then we stop. Okay, when n equals 7, so 14 squared, 7 squared minus 1, 48. 7 squared plus 1, 50 squared. But that's also all the numbers even. I have to divide by 2. 24 squared and 25 squared. That's it. So those are the interesting special triangles, right triangles. Okay. Now, using those right triangles, yeah, using right triangles, we can discuss some problems. Okay. So sometimes, okay, you are just given triangle. I want you to find the area. You know, you just study the area, right? Given triangle, this side is 16, other side 63, the third side 65. Find the area of this triangle. Now, when you solve this problem, right, you never heard about maybe 16, 63, 65. So, so first of all, make simple observation whether this is right triangle. If it's a right triangle, then you don't need to use the other formulas to find the area. Okay. So it's not on my list right now, right? So 16 square plus 63 square, as indeed as 65 square. Okay. So you check that, and then it is right triangle. If it's a right triangle, then the area is just equal to half of 16 times 63. Okay, that makes it easy, much easier. And then the answer will be 5 or 4. Now, if you do not recognize this is the right triangle, what else? What the formula can use to find the area? Right? You have to find the height. It's not easy to find height. So you have to use the Heron's formula. Okay? Another way to solve the problem, let's look at the Heron's formula. Okay? By Heron's formula. Heron's formula says that if you have a triangle A, B, and C, so half of the perimeter is this, then the area is going to be square root of S minus A, S minus B, S minus C. So yes, this is it's one formula, and it can completely determined by 3 sides. So the triangle is completely determined by 3 sides, of course, the area, but it's not easy to express the area in terms of the 3 sides, A, B, C. Okay, and he found this formula. All right, so let's look at this. How do you do that? So S is half of 16 plus 63 plus 65. Let's check. Okay, 128, 16. That's 4, 4, 1. Right? Yeah. So when you divide by 2 is 72. Okay. So the area is going to be 72. 72 minus 16. 72 minus 63. 72 minus 60, 65. Okay. But now it's, yes, you get the answer, but a little bit complicated. You have to get rid of radicals. Okay. And yes, you can do that, right? So simplifying 72. This is going to be 56, right? 56, and that is going to be and that is 72 minus, it's a 9, right? And that's going to be 7. Okay. Okay. So once you get this, you don't multiply this out. If you multiply this out, you're not able to get simplify. You're not able to simplify. You should instead multiply this out. You should factor each term. Okay. Right. 72 is 9 times 8, right? So 9 times 8, 56. 8 times 8 times 7. Okay, then 9 times 7. You see, you have double 9, double 8, double 7. Right? So it's gonna be 7 times 8 times 9. So the answer is still 504. Okay, it's a little bit complicated, but you definitely get an answer if you do the computation carefully. Yeah, of course, Derek, if you use a calculator, you multiply them out, you can do that. We assume you don't use a calculator, and then that's how do we, how do we simplify? Okay. There are some right triangles above. Let's see, we already mentioned. We can make some triangle, but I don't tell you at the very beginning. For example, we can have we can have this type of triangles. Right, this is a 12. Okay, 5, and that is going to be 12, 5, and 13. And I'm going to draw another one. Okay, and that's 35 and 37. Now, I use the 2 triangles, put them together, but sometimes you're not given all these informations. What you're given is 5 plus 30 is 40. Yeah, so 40. So you're given this triangle. Okay, if you're given this type of triangles, it's not easy to recognize this is you group 2 right triangles together. If you know that, then you can quickly solve the problem. Okay, so but if you see that 1337, you should know, if you can recall those 2 identities. Okay, if you recall those 2 identities, 5 square plus 12 square equals 13 square, and if you know 12 square plus 35 square equals 37 square, and then you will see possibly 12 that share the same height. If you can if you remember those 2 identities, that you can easily solve the problem. Okay. Find the area questions. Find the area. So I'm not going to destroy the original picture. Yeah. Okay, 40 is going to be 40 is going to be 5 plus 35, 35 in the 5, and this will be 12. Then done. Okay, then the area is going to be the sum of the area of two triangles. Okay, plus half of 12 times 35. Otherwise, how do we solve the problem? There are still a couple ways to find the area. If I can find the height, you can. Okay, I'm going to show you how to find the height. So this is the area. Okay, you already got 240. Okay, I trust you. Okay, I did not know that. The answer 240. Okay. Now I'm going to show you different ways, assuming you never, don't remember this. Okay. So here's a. So this is going to be. We're going to find the height. 13, 37. Here's x. Here's y. Okay. What you can do? I know that by x plus y is 40. Okay. That's the first equation. Then I have an x squared plus h squared equals 13 squared. Okay. Then also have a y squared plus h squared equals 37 squared. Okay. From here, you have 3 equations and 3 variables. You are able to find 3 variables. Okay, this is algebraic questions, right? How do we solve the problem quickly? We can. Equation 1, equation 2, equation 3. I find the h squared in both equations. We can cancel it out. So equation 2 minus equation 3. Right? Then what? Then x squared minus y squared equals x squared 13 squared minus 37 squared. Okay. I'm going to use my tape here. Okay.
Hi.
Okay. Who is talking? Okay. Okay. So why we do that? Because after we take subtraction, I get an equation x and y. So I'm able to find the x and the y first. Then I can get h. Then you get everything, right? The main point is trying to get h. Okay. How to get h? Right? You get h. You have an x plus y here. Okay. So I'm not going to do the computation here. X, then x minus y, x plus y. Okay, is going to be 13 squared minus the square. Okay, but x plus y is 40, right? By the first equation. So you get x minus y divided by 40. Now you can simplify it. Okay, you can simplify it if you use a calculator. We can eventually we can get, it's a negative number because x is smaller than y. Okay, so so you have a 37. Okay, and then divided by 40, so you get 30. Okay. All right, so x minus y is 30 and x plus y is 40. Not minus 40, yeah. So you can solve for x and y. Okay, so x plus y is 40. Okay, then you add them together. What do you get? Add them together, you get 2x. 40 minus 30 equals 10, and you get x equals 5. Okay, so once you get an x, you can get a y, and then you get h. H is going to be square root of 13 square minus 5 square, so it's 12. Then once you find the height, you can find the area, so you don't need to do the rest of that. So this is a typical example. You draw addition line. In geometry, the difficult part is to draw addition line to solve the problem. I already, for this same problem, I already mentioned 2 different methods. The first one, for first method, you have to memorize several special identities. Then you recognize, oh, this is you group 2 right triangles together. Okay. Now, if you do not memorize this, and they do not remember the above equations, you know, you cannot solve the three, you cannot set up the three equations, applying the Pythagorean theory, at least you can still solve the problem using Heron's formula, right? Yeah. So you still can use the Heron's formula to solve the problem if you just want to find the area, okay? If you do not recognize this is a, you know, this is a triangle, you growing two right triangles together, and if you're not able to draw addition line and to apply Pythagorean theory to find the height, then you still should be able to solve the problem using Heron's formula, right? So we can take, you know, 13 plus 40 plus 37, and then divide by 12 to 45. And the Heron's formula says that it's going to be 45 times 45 minus 13 times 37, 45 minus 37, and the 45 minus 40. Okay, so it's going to be 45 and 32. Okay, 45 minus 37, 40 minus 37 is 8, and 45 minus, yeah, it's going to be 3. So then you find the area, okay? And you know, I think it's easy to find the area here. So 15 is what? 45 is 3 times 15. 3 times 15. 9 times 5. Okay. And 32 is going to be 8 times 4, right? And 8 times 3. So, where's we missing some numbers? Better. Yeah. So you get radicals. Yes, H. No. 45 minus, 45 minus 40, sorry, not a, yeah, I wrote it 42, that's the reason, yes, thank you. Okay, so this, then that works, okay? So then you have 1, 3, 1, 5, 8, it's 2, okay? So 240, right? 3 times 8, 24, and times 10, okay? So you get the same answer. Now, so you see, you should be able to do, you know, this problem, one of the methods. I'm going to let you to try, okay? The next problem is, and here's an isosceles triangle, 17, 17, right? And the 30, okay? Find the area. Okay. Please do this problem. So Alex Gu answered many questions. That's okay, thank you. And I'm also wish those girls can give me the answers. Angelina, Colleen, Emma, Michelle, Vincia. Okay, do your best. Okay, so this is the isosceles triangle. Then you wanted to find the area. You have 2 different ways to solve the problem. I'll tell you, you know, it's up to you which way. You can use a calculator, okay? For problems here, you can use a calculator. Please do that, yeah. I'm gonna show you 2 different ways to solve the problem. Joshua, try your best. Huh? You got 120? Oh, Derek, you got 120? David. Oh, David changed mind. Right. All right. So there are two different ways to solve the problem. The first one is we try to find the height. You draw the line, okay, and immediately, you get a right triangle. And because it's an isosceles triangle, so the right triangle you can get here, this side 17, this side 15, this is an H, right? So if you remember the special triangle, you can get H right away. Otherwise, you apply the Pythagorean series, 17 square minus 15 square, take square root, okay? Because H square plus 15 square equals 17 square, okay? So from here, you solve for H, got it? So once you get H, then after you simplify, you're going to get 8. Now, if you do not have a calculator, how to get 8? Because 17 square minus 15 square can be factored out. Okay, so the first term is 2. The second term, right? Second term is 32. So that's why 64, and that's why it's 8. That's how to do that. I didn't use the calculator. That's why how do I get the 8? So once you find the area, find the height, then you get, 120. Okay. Okay. Yeah. 8 divided by 2 is 4. 4 times 30 is 120. Now, if you want to, you can also solve the problem using Heron's formula. Okay, and you get the same answer. Let's do it. Okay, so 17 times plus 17 is going to be 34, right? Then plus 30, and then divide by 2. Yeah, it's 32. Right? Then the area is going to be 32 times 32 minus 17, 32 minus 17, 32 minus 30. Okay, so do not multiply this out. You just do the calculation. Okay, so this you get 15, you get 15. That's okay. So 15 is 15 squared, you can take out, right? 32 times 2, 64. 64 is 8. Square of 64, 15. And again, you will get 120 again, right? So same answer. It's also pretty fast if you know how to do the computation with numbers, okay? Right? Great. One more problems. Jonathan, are you there? I wish you can work out this problem, okay? This is a triangle. Oh, okay. Before we do this problem, I'm talking about special triangles. Yeah, the special triangle is as follows. Okay, special triangle. If this angle is 30, okay, and the other one is this is a right triangle, and this is going to be must be 60 because then 60 plus 30 plus 90 is going to be 180 degree, right? The sum of 3 triangles, sum of 3 angles in the triangle is 180. Okay. Let's find the relationship among the 3 sides. This is a C, this is A, this is a B. Okay. We find out for this special triangle, A, B, C are related in a very special way. Okay. So what I'm going to do is I double this triangle. Okay. So this will be straight line. Now it's a 60 degree, right? And that's also must be 60 degree. But this is 30 and this is 30. So total is 60. What do you get? You will get an equilateral triangle, right? So this is a C, and here's A, here's A, here's a B, here's C. So that means immediately you can get 2A equals C, right? Yeah, because all the three angles are equal. This is the equilateral triangle. All right, so 2A equals C. In other words, A over C equals 1/2. But how about the B? What's the relationship between B and C? That's okay. We use a Pythagorean theory. Okay, B over C. Okay, A is a half of C. Okay, so A squared plus B squared equals C squared. So A is a half of C. Can I solve for B? Yes. So it is 1 minus a quarter. It's a 3 over 4 and C squared. Then you take a square root, and you get square root 3 over 2 and C. Okay, that's the relationship. Okay. So let me repeat again. If we have a special right triangle, and this is 30 degree and a 60 degree, that's a C, this is A, and this is B. A is going to be half of C. B is going to be square root 3 over 2C. Okay. Now, if you have a 45 degree here, that's a 45. It's a 90 degree. In this case, these two sides must be equal. A and A must be equal. Okay. It's isosceles right triangle because these two angles is 45, 45 degrees same. But so 2A squared equals C squared, and A squared equals half of C squared. And you can solve for A. A is going to be square over 1/2 times C squared. Now, if you rationalize the denominator, you get this. Okay. All right. Here's my question. If we are given an isosceles triangle and A, express the area in terms of A. Right. Can you do that? Alan, your answer looks bad. 0.25 A square root 3. That's not the way we write. Right. Oh. Okay. Emma, do you have answers? Yeah, Jonathan, you have a question? Now, again, there are several ways to do this. Yeah, the edge length, the side length is not specifically given, right? So how to express area in terms of A? You have two different ways to solve. First, you find the height, right? Right? Find the height. So this is the height. But the base is half of a, right? Right? So applying the Pythagorean series. So h squared plus a over 2 squared equals a squared. And h squared equals a squared minus a squared over 4. It'd be 3 over 4 a squared. Right? Then you solve for h, which is going to be square root 3 over 2a. Okay. Then once you have h, you can express a, right? Half of a times h is the base times height. So base times height. Height is square root 3 over 2a. So after combine them, you have a square root 3 over 4a squared. So we use a Pythagorean theory to find the height. Then once you know the height, you can multiply them out with the base. Then you get the area. Okay. But you can also use a Heron's formula. Whenever someone trying to give us 3 sides to find the area, you can always use a Heron's formula. If here's a, here's a, right? So the half of a plus a plus a, which is 3a over 2. Okay, that's it. Half of the parameter. So area is going to be, remember, right? S minus a, S minus a, S minus a, right? So using that formula, then you can solve the problem. Here's 3 over 2a, S minus a, 3 over 2 minus 1, which is half. 1/2. 1/2. Then what? Then you get 3 over 2 times 2, right? It's 4. It's 4 square here. A square. So that's why you get square root of 4 and times 8. So it's also quick, right? You do have some good ways to solve the problem. Right. Okay. Trying another one. I'm going to give you this triangle. Okay. B, A, C, right? So we know that BC is a square of 3. D is on the side AC, and we also know that AB equals AB equals BD equals AD equals DC. Okay, those are all equal. Okay, so what is the area of the triangle ABD? ABD. Okay, and I want you to find the area of this triangle. But look at the assumption. This triangle is an isosceles triangle, equilateral triangle. Okay. Anyone who can try? I'll give you 1 minute. Okay. My hint is, here's my hint. Oops. Here's my hint. This is 60 degree, 60 degree, and 60 degree. That's 120 degree. Okay, and here square 3. And all the sides are equal, right? So you can tell you can tell that this will be 30 degrees. That'll be 30 degrees. Then it's easy, right? So please do the stuff. What do you have to find out? You have to find out the edge length of the equilateral triangle. But all those four sides are equal. Okay. Oh, nobody give me an answer? Oh, really? William always. Okay. So take a look at it. Okay, those are all the same. A, and A, right? So now you have a triangle, and isosceles triangle. Here's 120 degree, and this side is square 3, right? And here's 30 degree, here's 30 degree. So you draw the line here, and you get another triangle, right triangle, right? So you have a right triangle, special triangle, and this side is square 3/2, 30 degree. And here's A. What you should get? A must be equal to what? Equal to 1, right? Yeah, because this will be 60 degree. So A is 1, okay? Yeah, A is 1. A must be equal to 1. So therefore, if we have A is 1, the area is going to be square 3/4. A square, that's a square 3/4. All right, great. All right. All right, let's try next one. I have let's work on the let's do a little bit easy one. Let's skip that problem and go back. Okay, I have a triangle. We have triangle A, B, and C. Okay, this triangle AB equals 2, and ABC is 30 degree, and that's a 45 degree. And then you have to find out the side AC. Angelina, you haven't given me any answer yet. Oh, yes, you have one answer before. Okay, great. You did good. Tobias, are you there? Tobias. Yeah, 30 degree, yes. Okay. Can you work out this problem? Kevin already solved the problem, sounds like. All right. This is a 30 degree, yeah, it's a special triangle, 30 degree, 45 degrees. So what you get here is you have we grew two special triangles together. This is the line, okay? So it's for 30 degrees, then H must be equal to 1, just because this angle is 30 degrees, okay? H is half of the other side. Then since this is H, so this we call it X, then X must be square root 2 times H. If you know H square, and because this must be 45 degree, okay? This is 60 degree. If this 60 degree, that must be 45 degree, because the total angle as a sum of these three angles must be 45 degrees. So this is the 45, 45, you get an isosceles right triangle. And then you can apply Pythagorean theory to this, right? So that's the reason you get 2 equals x squared. That implies x equals square root 2. Okay. Okay, so here's another one. Okay, this is A, B, and C. And BC is a 63. And this is right triangle. Okay, right triangle. Okay. BC equals 3 and AC equals 16. Yeah, find the height. Find the DC, the height. Yeah, how do we find the height? We have 3 different ways to solve this problem. You must figure out one of them. Joshua, I haven't called your name. One solid. Wow, my God, it's a big number. If you solve the problem using one method, you can try use a different method. Okay. Okay. So. Vincia, are you working on the problem? Are you there? No, you don't answer my question. Yes, okay, good. Good job. Fine. All right, so I'm going to show you a couple of different ways to solve the problem. Okay, we needed to learn as many methods as possible to solve the problem. First of all, you know you are told this is right triangle. So AB, okay, is going to be square root of 63 squared plus 16 squared. Okay, and then you what? Then you get 65, right? Okay, that's the one. Once you get that, you can use the area to solve the problem. Let's call it H. Okay, so the area of the triangle is going to be half of 16 times 63. Okay, that's just the area divided by 2. But you can also calculate the area using this method. Okay, so therefore, okay, therefore if you then you get 16 times 63 divided by 65. Okay, of course it's 11865. Okay. That's one way to do. Another way to solve the problem, okay, using the similarity triangle. And this is right triangle, right? 63 and 16. So I draw the line, and this is H. Okay, so this side must be 65, right? Yeah. So I cut this triangle and compare with the larger one. See, I cut it and put aside. So I put this in this way because that's 16, and yeah, this side is the H actually. Okay, so those two triangles are similar. They are similar to each other. Then the ratio of the corresponding side are equal. So so 63 divided by H, those two sides should be equal to those two sides. 65 divided by 16. Okay, then and why is those two triangles similar? First of all, if this is called alpha, right? And after you cut this angle, flip it over, this is still alpha. That's why the corresponding angles are equal. Okay, you have a 90 degree, 90 degree, then alpha and equal alpha. So that's why those two triangles are similar. All right, then H is going to be 63 times 16 divided by 65, and this is okay. You get 1. Yes. Now the third method is we already did it before. Use the 3 equations. Pythagorean theory. Use 3 equations. Applying Pythagorean theory to solve the problem. Okay. Since I don't have much time, I'm going to skip that and work on the last problem. Okay, I have a rectangle, and this side is A, other side is B, and this is diagonal. Okay, so I know that the perimeter is going to be 20. Okay, inches. The area is going to be 9.5 square inches. Okay, find the length of the diagonal. Okay. Okay. So the length of the diagonal is going to be what? So what we're given? We're given the given information, right on the given information. Perimeter is 20. So that means A plus B is half of the perimeter, which is 10. Okay. I also know that A times B is the area. That's going to be 9.5. So 9.5 is going to be what? It's 19 over 2 if you don't use the decimal numbers. Okay. What do we want to find out? We want to find out the square root of A squared plus B squared by the Pythagorean series. The length of the diagonal is going to be square root of A squared plus B squared. Okay, that's a D, which is D is going to be the length. Square root of A squared plus B squared. Okay, that's my hint. Can you try? Joshua? William, how did you solve the problem? By guessing, try? Oh, Catherine, I did not see you. Just you show up right now. Hello, Catherine. Catherine. Okay. All right, we get a bunch of answers. Angela, Lou, great, good job. I'm glad to hear you. Okay. All right, so look at this, right? This is the algebraic problem, actually. You know, you write down two given information, and two algebraic questions. Oh, okay. All right, so you want to find a squared plus b squared. Okay, so a plus b squared. This is very important identity. I keep talking about this. Okay. Then from this identity, you see that you are given a plus b, so it's 10 squared. And you don't need to find ab, right? You find a squared plus b squared. And then a times b is 19 over 2, so you cancel it. Okay? So 100 is going to be what? 10 squared is 100 equals a squared plus b squared plus 19. Right? So a squared plus b squared equals 100 minus 19 is going to be 81. So that's why d is going to be square root of 81, and which is 9. Right? So 9 is the answer. All right. All right, so this is answer. Okay, so we discussed almost all those problems, and you are going to get the notes, okay, including the homework problems. You don't cheat on yourself. You have to, okay, you have to finish the homework, do as many problems as possible. Some problems you cannot do it, that's okay. You may ask your parents, send me the list of problems you cannot solve if you need help. Some parents, okay, can help you solve the rest of the problems you are not able to solve, but not everybody. Right? So we can discuss a couple of the problems in class before the class begin. Right? So if you do not do the homework, you're not going to make progress. Okay? So that's my suggestion. Since most of you stay home these days, it's not a good time, you know,